sure that we kind of understand how these work. So a lot of them are just going to be like question 4. And there's not much to question 4. Don't try to make question 4 too difficult. They're not working with it at all. All we need to figure out on question 4 is this an equation or is this an expression? That's it. So don't try to solve it. Don't try to make it more difficult. We've talked about that. Which one do you think it is? Equation or expression? Equation. Why is it going to be an equation? As an equal sign. That's it. So a lot of times when I assign problems like this one, students try to do all kinds of things to this question. No. All you have to do, always read the directions, is either it's an expression or an equation. So don't try to do anything else. Don't try to overcomplicate it. Always make sure that you read these directions. And like question 5, we're not going to go through it, but we've talked about it, right? We come up with our equation, and then we check these numbers to see which one's going to work. And there's only one answer that'll work. So once you find the number that works, you're done. Okay? And like question 6, order of operations. Well, what would you do first for question 6? If I plug in that 2, do we have any parentheses? No. But we do have exponents, right? So before I start multiplying or doing anything else, what's the very first thing I would do? Exponents. So you would cube it first. That's all I want you to tell me, is that you would just cube it first. A lot of these are things we've talked about. So you shouldn't have too much of problems with 1, 2. If you do, we always have time at the beginning of every class period to go over questions in the homework also. Yeah, I think that just covers most of these. One, though I want to make sure we understand what to do, is question 18. Just to make sure we understand what's happening on 18. This 4, they wrote it like that, but what that really means is you're going to plug in x equals 4. So that I wish they would have put the x equals 4 there, but they just put the 4 with the colon out the end, or semicolon. So what are you going to do? You're going to plug that value of 4 in, right? And what does it mean if something's a solution? A solution means the sides are the same, right? So they're going to come out to be the same number. So it's going to be a solution if I plug this 4 in and I get out a 75. That means it's a solution. If it's 62, if it's 81, it's not a solution. So you're going to plug in that 4, you're going to work it out, and if it comes out to be 75, that means it's a solution. If it does not, it's not a solution. But again, I just wanted to make sure we understood what that 4 in the end means. And that's just simply x equals 4. Same thing with 20. On question 20, you're going to plug in that x equals 9. That's it. Right? Plug it in, see if it works. So that's what you'll be doing on those. So that should let you get through 1.2. We're now going to move on, and we're going to start talking about 1.3, which is absolute values and the signs of numbers, and how sign numbers work, and the different types. So in 1.3, we're going to talk about all the different types of numbers. So when we talk about these numbers, we've got different types, and we're going to talk about them just so it's easier to understand and relate to. We're going to talk about them in terms of an animal from the animal kingdom. So the first one we're going to look at is real numbers. And then we're going to see how this relates to biology in the animal kingdom. Now, real numbers are going to be all numbers. So all numbers that we work with are real. So all numbers are going to be real. So examples would be 4, -12, 1/5, -3/8, 9, 0. So all numbers are going to be classified as real numbers. Now, just like if you were looking at the animal kingdom, when we talk about animals in general, that can be reptiles, amphibians, that can mean warm-blooded, cold-blooded, everything's an animal, right? Okay, so all animals are animals. In this class, we're working with numbers, so all numbers are real numbers. So all animals are animals, all real numbers are real numbers. Then we can divide that down. So then we can divide that down into rational and irrational. And we'll talk about rational first, and then we'll break it down a little further. So we're now going to look at rational numbers. And what rational numbers are is these are going to be integers. We've got fractions. Fractions are rational numbers. Decimals that either terminate or repeat. So those are going to be our rational numbers. Also, just so you know, zero's in there too. Zero's an integer, but we'll just go ahead and make sure we understand that zero's in here. So when we talk about rational numbers, we're going to be looking at the integers, we're going to be looking at fractions, decimals that either terminate or repeat. Zero's also in there. Zero is an integer, but I do like to put it in there just so you remember zero's a rational number as well. So here's some examples. So these are all going to be examples of rational numbers. 1/3. 1/3 is a rational number. Why? It's a fraction, right? Fractions are rational numbers. 0.743. That's rational because it stops. It's a decimal, but it does stop. It terminates. 0.9 with a bar over it. Right? That bar means it repeats. So that 0.9 with the bar on top, that's 0.99999 goes on forever. Okay, so it repeats, so that also makes it rational. How about -12? That works because -12 is an integer. 0 is also in there, and 9. So those are all examples of rational numbers. Now, when I think about rational, and what we're going to look at next is irrational numbers, when I think about that and I think back to the animal kingdom, well, there's male and female, right? Two sexes on the animals. Just like there's two types of numbers. It all goes kind of together. So that's why I like to use that analogy. So you got male and female in the animal kingdom. And in numbers, you have rational and you have irrational. Now, irrational is basically everything that's not rational. And irrational numbers are going to be decimals that never terminate or repeat. And also special numbers like pi. So let's look at some examples of these. And these are going to be irrational numbers. So this is an irrational number, 1.4563219 ... Okay, the ... that means it goes on forever. So that number never stops, it never repeats itself, it goes on forever. And also pi is an irrational number because pi is 3.14, I think it's 76, it goes on forever. I think I got the decimals right there. And while you work on that, I'll just go ahead and write this down. 1.5. Sorry about that. 1.5. It goes on forever, though, right? And so pi goes on forever, so that's why it's irrational. So if it's a decimal that never stops, never repeats itself, it's irrational. Now, we're going to look at this in terms of a tree diagram. So what we've got so far is we've got three different types of numbers. So we've got real. And when we look at real numbers, all numbers are real. So real numbers are at the top. And then we can break this down into either one or the other. Rational or irrational. Male, female. Animals up top, male, female, two different types. And then we might be able to break down, well, we can break down the rational side further. And we can break the rational side down into integers. We can break that down then further into whole numbers and natural numbers. So let's think about a bear, okay? If we talk about a bear, bear is an animal. Let's say we have a male bear, so that takes care of one category. And what else do we know about that bear? Well, that bear has fur, so that's one type that it is. Warm-blooded and so on, right? All the different things that a bear is. These are the categories, just like numbers, same way. We can break that generalization down into different parts. Irrational, though, we cannot break that down, but the rational side we can. And how these were created, or wrote down, is how they were kind of created and how man made his journey through numbers. We'll talk about what these are in a moment, but when we talk about natural numbers, okay, this is the first type of number that man had. And that's basic counting. Okay? And no negative numbers, because when you're just counting sheep on a field, you don't know what a negative sheep is. You don't know what 0 really means either. You just know, okay, I got five sheep. That's about it. And then after that, after man had been working with basic counting, they said, okay, we need to deal with 0, because we talked about what 0 actually means. Okay, and then once you figured out 0 and you placed 0 as meaning nothing, then man decided to start work with currency, and so then debt, and so then they came up with negative numbers. So those are included in the integers. And then decimals, fractions are above that. So we start off with only positive numbers, then we include 0 in whole numbers, and then we start talking about positive and negative, because that's currency and you have to have debt. When you borrow money and trade, that makes negative numbers. So we've talked so far about rational, irrational, and the real numbers. We need to go ahead and clarify, though, the integers, whole numbers, and natural numbers. So we'll just start next with the natural numbers. And then we're going to talk about numbers, and we're going to have to classify them. And they can be multiple types. So we're going to go ahead now and talk about our definition of natural numbers. And some textbooks call natural numbers counting numbers, because they're numbers that you can count on your hands and fingers, okay? Hands and toes, or fingers and toes. So natural numbers are things you can count. So these are going to be positive integers, not including 0. And let's look at some examples. And the textbook has definitions too, but their definitions I think are kind of confusing. So I like to give you ones that you can really relate to and really understand. Okay, so natural numbers are going to be positive integers, not including 0. So these are all positive numbers, no fractions, no decimals. Okay, fractions and decimals are not integers, not part of this. So when we look at natural numbers, that's things like 1, 2, 3, 4, 5, and so on. Those are natural numbers. So that's the first thing that man developed, was just basic numbers. And then we went through and discovered 0. So whole numbers are the natural numbers including 0, or positive integers, also 0. So 0 is the only difference, and 0 is a whole number. So same examples as before, only 0 is a whole number. So we've got 0, 1, 2, 3, and so on. So those are whole numbers. And the last one is our integers. And integers are positive and negative whole numbers. Plus 0. Because 0 is also an integer. So we're looking at positive and negative whole numbers, and that also includes 0. So let's look at some examples. And these can be positive or negative. Now, very importantly, integers, no fractions or decimals. None of these have fractions or decimals. So some examples might be negative 12, positive 14, 0, 9, negative 10. Those are all going to be examples of integers. So what's an integer? Positive and negative whole numbers. Now 0 is also in there. A lot of times people get confused about 0. 0 is a whole number. I chose to put 0 in there as well. To put that plus 0. Just so you remember, 0 is in there. 0 is an integer. Now we're going to classify these numbers. So I'm going to give you some numbers, and we're going to learn how to classify these. So we're going to go through them all, and we're going to talk about how we would classify them. So I'm going to give you numbers, probably do 3 or 4 of these. We're going to classify them. Now, these can be more than one type. So we're going to classify the following. Let's look at minus 10. Now, how we determine what it is we look back at our tree that we wrote up a few minutes ago. So we're going to go back to that tree. I'll just pull that down here. So if we got up to this point, we're going to look back at our tree. Now, we're looking at negative 10. Okay, now, when we look at negative 10, we need to first talk about negative 10 in terms of rational or irrational. Okay, so is negative 10 going to be rational or irrational? Now, remember the definition. Rational, what's rational? Integers, whole numbers, fractions, decimals that either terminate or repeat. Well, negative 10, right, that's an integer, isn't it? Okay, so it's going to be rational. what would be irrational? All the decimals, things that never stop. So negative 10 is definitely rational. Then we start at the bottom of the rational side. Since it's rational, is negative 10 a natural number? No. Why not? Natural numbers have to be positive. Is negative 10 a whole number? No. Because again, whole numbers are just like natural numbers, except 0 is part of that. But is negative 10 an integer? Yes. Then we follow it up. So negative 10 is an integer. We follow it up. It's rational, and it's also real. Everything's going to be real. All these are going to have real as a part of it. So negative 10 then would be integer, rational, real. What about minus 1.743892 ... If I gave you this one, what do you think about this one? Well, rational or irrational? Irrational, right? Because the dots mean it never stops. So if we go back up to our tree, the irrational side doesn't break down. So decimal that never stops is irrational, and we follow it up, it's also what? Real. So this decimal that never stops would be irrational and real. How about 0 itself? What do we think about 0? Is 0 going to be rational or irrational? It's rational, right? Okay, because that's the easy part, because what are irrationals? Decimals that never stop or repeat themselves. So if you have a really long decimal that has a dots at the end, it's irrational. Everything else is going to be rational. Now, what about 0? Okay, 0, is 0 a natural number? No, because when man first came up with numbers, he had no concept of 0. But then we start progressing, and we get whole numbers. So 0 is a whole number, and it's everything above that as well. So it's whole, integer, rational, real. You find it on the tree and move up to the top. So 0 has multiple parts as well. So 0 is whole, integer, rational, and real. Okay. So that's what we're looking at there. 0 is a whole number, integer, rational, and real. I did put several of these thinking questions in your homework, and I'm going to go over one of them with you. So let's look at 12. Okay, so we're going to look at 12. And there's a couple of these. These are either true or false here. And we have to think about our definitions in a broad sense and try to see if this is true or false. So we're going to look at 12. Some real numbers are integers. Is that going to be true or false? Well, what does it say? Some real numbers are integer. Okay, so let's take a real number. How about 5? 5 is a real number, right? Is it also an integer? Yes. So it says some real numbers are integers. That's true, right? Because 5 is an example. Try to find an example. Well, 5 works because 5 is a real number and it's also an integer. So yes, there are some real numbers that are integers. Now, if it would have said all real numbers are integers, if it would use that all there, what would that be? All real numbers are integers. That would be false. Why? What about 1/2? Is 1/2 a real number? Yeah, but it's not an integer. See, if that word would have been all in front, it changed the whole question. So when we work through these, we need to make sure we read it a couple of times if we need to, really think about it, really digest it. And that sum means there's only a few, and there are a few numbers that are both real and are integers. And there's a couple of other questions like this also. So now that we've classified these numbers, we can now move on to look at sign numbers. And we're going to begin with by talking about absolute values. And absolute values, they're absolute value bars, and what they do is they make the number come out to be positive. So we're still in 1.3, and we're going to look at absolute values. And we'll look at absolute value bars. And absolute value bars are like this. So move it so we can see it. So we're going to be looking at absolute value bars. Vertical bars, those are absolute value bars. And what absolute value bars do is they're going to make the number come out to be positive. Make the number come out positive. Or 0. Because the absolute value of 0 is 0. So it's either going to make it come out to be a positive number or 0. So here's some examples. Absolute value of minus 5. Absolute value of minus 5. We make it positive, so that is what? 5. Absolute value of 4 plus 3. So these are all going to be examples here. So we'll try to do several examples. Okay. Absolute value of 4 plus 3. Well, what are we going to do with this one? Absolute values, they behave just like parentheses. So we're going to take that 4 and 3 and we're going to add them together. So 4 and 3 is 7. And now we can take the absolute value of 7. And the absolute value of a positive number stays what? Positive. So all absolute values do is make it come out to be positive. Now, if it's inside, we don't change it. We don't make the negatives inside positive. We just work it inside. Absolute value is done at the very end. So here's another one. Absolute value of 8 minus 12. So how do we do this one? Now this is bringing up signed numbers. And we're just starting the introduction to signed numbers. So when I talk about signed numbers, I always like to think about money. So my bank account has $8. And I go do a transaction that costs $12. That makes me overdraw my account by $4, right? Because you've got $8, you take out 12, that makes it -4. So I did the inside first. So order of operations, inside. Now we take the absolute value. And what's the absolute value of -4? +4. Here's where students get confused is on the next one. This is a very, very easy expression. But students really get confused because they try to jump ahead. Someone's going to look at this and they're going to say, well, I remember from my previous classes that I've got these double negatives here, and a negative and negative will make it positive. We can't do that in this case, because before we do multiplication, the very, very first thing we have to do is absolute value. Remember, absolute values are at the top. When you cancel these out, that's multiplication. So what we do is we do this piece first. And what's the absolute value of a -9? +9. Okay. Now, what's still out in front and gets dragged down? So what would my final answer then come out to be? Negative 9. Not positive 9, negative 9. I'm going to pick a couple of questions from our textbook here to look at that have absolute values just to make sure we know how these work. How about we look at, we'll just do one of them. How about page 50, question 62. And I do like to pick problems from our textbook. You know, we have our textbook, might as well use it. I make up a lot of questions as well. So I kind of pull from the textbook, and I kind of create my own also. Question 62 is just kind of like what we've talked about already. Okay, now how do we handle this? Well, 9 minus 4. What's 9 minus 4? 5. Okay, so that 5 comes down. That negative in front comes down. And you want to make sure you don't think that's 151, so we're going to write the absolute variables. We're going to make them bigger so we don't make that mistake. Okay, now, absolute value of 5 is what? 5. But what is out in front of it that just gets dragged down? Negative. So it's not positive 5. My answer would be negative 5 because that negative in front, it just follows it down. It just gets dragged down. Right? Negative is not inside, it's outside. So it follows it along. So now we've talked about absolute values. And we've talked about the different types of numbers. When I talk about opposite means I change the sign. So just to make sure we understand things, I do work out homework questions sometimes, just because that kind of keeps you focused. Because when I do homework questions, you're likely to write them down and work them out. Helps with other ones. Let's look now at question 8. I'm going to work through question 8. We've got some fill-in-the-blank numbers we're going to look at. Now, when we talk about opposite, that means change the sign. So opposite just means change the sign. So the opposite of negative 7 is positive 7, right? We switch the sign. So opposite means we're going to switch the sign. What about the absolute value of negative 7? Well, the absolute value of negative 7 would be what? Not negative 7, the absolute value of negative 7, right? The negative 7 is inside. I'm going to take the absolute value of that negative number. What would that come out to be? Positive 7. The opposite of the absolute value of negative 7. Okay, now, what did we decide the absolute value of negative 7 was? 7. And what's the opposite of 7? So that one will also be negative 7. Okay, what about the next one? The absolute value of the opposite of negative 7 is blank. Okay, so the absolute value, so we're going to be working with here, of the opposite of negative 7. Well, what's the opposite of negative 7?
7.
Positive 7. And what's the absolute value of 7? 7. So the answer for that one here would be 7. Okay? And got to watch the order too, like on this one, the opposite of the absolute value. So that means we do the absolute value and then switch the signs. That makes that one negative 7. I wanted to work this out just so you'll see. I think there's another one like this one. Later on in your homework, you just have to look at the opposites. What does opposite mean? Change the sign. And just to make sure we understand the next ones here, if it helps, you might want to make sure these absolute value bars are bigger so you see them. Sometimes on the print, the absolute values look tiny. So If you need to on the next ones, make sure you see those are absolute value bars. So now we've looked at most of 1, 3. We'll look at some more and review some fractions, because I think we need a little bit more of a fraction review. And then that'll take up the rest of the class. So we finished up 1, 3. We talked about absolute values. We've talked about order of operations. I do want to do some more questions that involve fractions, just to make sure we have a good review of fractions. So let's do a review of fractions. Okay, so here's one that we're going to look at, because we've talked about lots of things. Most concepts today are not really that difficult, but I know absolute values are, and we need, or not absolute values, fractions are. So we need to make sure that we really focus on some of these fractions, because fractions come up everywhere. So here's another problem that involves fractions. We'll probably do 3 or 4 of these. And this one is going to make us multiply. It's going to make us do order of operations. And so we want to work with this question here. There's lots of steps in this one, so I'm going to break it up into smaller pieces. And we're going to do a little bit at a time. Order of operations, parentheses go first, don't they? Okay. So let's work with our parentheses. I'm going to write that 1/4 plus the 2/3 over here. What are we doing? Well, we are now having to add fractions together. So when we add fractions, do we have to have a least common denominator? Yes. Okay. When we multiply, do we have to have a least common denominator? No. So we are adding, so we have to have a least common denominator. And what's the least common denominator of 4 and 3? 12, right? Okay, why is the least common denominator of 4 and 3 going to be 12? Does 4 go into 3? No. 4 times 2 is 8. Does 8 go into 3? No. But 4 times 3 is 12, and does 12 go into 3? Yes. So our least common denominator is 12. So now we're going to need 12s down below. Four times what makes it 12? Well, that's easy enough. 4 times 3, so that's 3 and 3 here. And 3 times what makes it 12? It's 4 and 4. So 3 times 1 is 3. 3 times 4 is 12. 2 times 4 is 8. 3 times 4 is 12. Okay. What are we going to do next? We are adding them. Now, do we add the denominators together, the bottom halves? Do those get added together? No. Okay? We're not multiplying, we're not changing it. So what is our denominator going to be? Down below, 12. They all have a common denominator of 12. Now we can add the numerators together. So 3 and 8, add those together. 3 plus 8, that makes it what? 11. So that just came down. Now what are we going to do? Well, we've got the middles done. We've got the parentheses done. Now we need to multiply. And we can't always reduce. This is an example of when we can't reduce. 5 and 12 have nothing in common. 8 and 11 have nothing in common. so we can't reduce it. All we need to do is multiply across. Okay? So 5 times 11, that's 55. So that's where that came from. Oops, let me clear it out here. Right, 5 times that 11, that's that 55 on the top. And what about down below? Nothing cancels. That's 8 times 12. And 8 times the 12 is your 96. Now, least common denominator of 96 and 3. Let's begin with the 96. 96, larger number. Divide that by 3. Does that go in there evenly? Yes. So my least common denominator is not 32. The least common denominator is going to be what? 96. Right? You see how I got it? I made this one pretty easy. So now we have that 96. We need a common denominator. The first one we're going to leave alone because it already has the 96 there. And that's our common denominator. So it stays the same. What about the next? Well, we need 96, and we're going to take that 96 and we're going to divide it by 3. And 96 divided by 3 is what? So that means inside this box, we're going to need 32 over 32. Now we've got 55 over 96 plus 32 over 96. We're going to go ahead and add these together. And add that 55 and that 32. Add them together. And that gives you now 87 over 96. Hopefully this helps a little bit with the fractions. I think fraction review is something that's well spent on our time. So I really want to try to do a couple more of these if we have enough time. Fractions are one of those things we cannot do enough of. Let's talk now about a fraction. We're going to have to square and add to another fraction. So this has got multiple fractions in it. And first thing we're going to have to do is work with that power. And 2/3 quantity squared. Now we talked about exponents earlier. And when I talk about this 2/3 squared, what does that really mean? Well, when I say a number is squared, it's multiplied by itself, right? It's 2 of them. So how would I handle a fraction when it's squared? Write it out twice. And multiply. Simple as that. Don't try to make it more difficult than what the problem really is. So now we're going to go ahead and just multiply across. Nothing cancels. So 2 times 2 makes it 4. 3 times 3 makes it 9. Now we've got 4/9 plus 1/4 minus 1/8. There's different ways of approaching it from here. We can do all 3 of them at once. I am going to just do it 2 at a time. I think it's easier for most students if we just do 2 fractions at a time rather than 3. So let's just take the first 2. We're going to work from left to right. So let's just take those first 2, and let's see what we can do with those. Okay, so we've got the first 2. We're going to go ahead and break those down. So we've got 4/9 plus 1/4. Can we cancel the 4's out? Can I cancel those out? No. Why not? Okay, sometimes students will see those and say, I can cancel those. Can't do that. Why not? This is not multiplication, is it? This is addition. So you can't cancel in addition, only in multiplication. What do we need? When we add these together, common denominators again, right? Least common denominator of 9 and 4 is going to be what? Let's work through it. 9 doesn't work. 9 times 2 is 18. Doesn't work. 9 times 3 is 27. Doesn't work. 9 times 4, though, is what? And it does work. That's going to be 36 is our least common denominator. See what we've got here. 9 times what makes it a 36? Well, 9 times 4. And 4 times 9 on the second one makes it the 36. So 4 times 4 is 16. 4 times 9 is your 36. 9 times 1 is 9. 4 times 9 is 36. Common denominators, I mean, they can go together. We've got 9 and 16. That should make it 25, doesn't it? 9 and 16 go together to give you that 25 over 36. Is everyone all right with that so far? Let me see how we did that. Now we need least common denominator. So let's try to get our least common denominator. By the way, the right-hand side, this can be kind of a mess, and sometimes it is. You've got lots of things going on. The very important part, though, is to make sure that you always have this piece here that's clean, so we don't have extra numbers running around. That's why I like to separate it with the line there. But let's try and find the least common denominator of 36 and 8. Okay, well, we're going to start off with 36. 36 divide by 8. Does that work? No. 36 times 2. What's that? 72. Divide that by 8, and guess what? It works, doesn't it? So what's our least common denominator? 72. See how easy that was? No problem at all. Okay. And what do we need here? Well, 36 times what makes it 72? We need a 36 times 2, right? So we need a 2 over 2 here. Is everyone okay with that so far? If I'm going too fast, be sure and say something, because I can slow down if I need to. Okay, what about the next one? If you can't see it, you just take your 72, we need to be by 8, so 72 divided by 8, that gives you the magic number, which is a what? 9. So what goes in the box, or in the parentheses here, is a 9 over 9. How we can finish it out? So 2 times 25 is 50. That's over 72 minus 9 over 50. Oh, sorry, over 72. And 50 minus 9. 50 minus 9 is a 41 over 72. Is everyone okay with that so far? And I don't think we have quite enough time to do another question, so we'll stop here. Now, just so we know what our homework is. What's our homework going to be? What have we covered? Our homework, we have done 1.1. You should be able to do them all. 1.2. Should be able to do them all. 1.3. You should be able to do them all. So that's going to be your homework, first 3 sections. I also want to real quick show you how to get into Canvas, because a lot of you may not know, because if you had Blackboard from last year, it's a little bit different. If I can get out of here, I'll show you where Canvas is. It won't take long at all. I just want to show you what Canvas looks like. If you haven't been into it yet. you just go to our web page, same way you would access Blackboard. So exact same way you used to access Blackboard, except instead of Blackboard, we moved to Canvas. We're LMS. So we're going to use our Canvas account here. Same as what you use for Blackboard, student ID number. Mine's a little bit different. I got the right password in here. Okay. Okay, I remember what my password is. I've got it. Yeah, there we go. Okay, and you'll log in. Now, you'll only see your one, maybe two courses. If you're taking online classes, they'll be in here too. We'll go ahead and find our class just so you see what it looks like, and I'll put it under the student view. Okay, ours is right here. You won't have this many. And this is what yours will look like. Okay, so this is just kind of what it looks like. I can post announcements. So when I post your videos, I'll put them up here. So you'll see them coming in here. I'll also put them under the modules. Because here's your homework. You don't turn it in online. They're just in here so I can add the scores in. Okay, because they're turning on paper pencil. So once you turn it in at the end of the chapter, I'll grade it, put it in your grade book. So again, don't have to do any homework online. It's all submitted on paper pencil. They're just in here so I have a place to put your grades. But that's your first chapter, the review of the real number system. Now, I pick up homework at the end of the chapter. So once we finish up chapter 1, then I'll pick up that whole packet at once. That way, if you want to, you can go back and redo things. Because a lot of times, students figure out when they go home, they work out questions, they think, I know what I'm doing. And then they come back to class and people ask questions and they figure out, oh, I made a lot of mistakes. And so instead of just turning in that work that's not correct, you can go back and fix it. And so I don't pick up homework until the very, very end. But again, the videos will be posted where you can see, watch the whole video if you want to, and the notes too. So there'll be a document where you can actually just view the notes and download and copy those. Well, I will see everyone then next week. And again, if you're gone because of COVID or something like that, you need to let me know so that I can let our student services director know. And I will see everyone then next week.